Hello and welcome to my presentation about the motion of double pendulum systems. I wanted to investigate double pendulums because I quickly came up with a simple schematic of how to make one that would greatly increase my understanding of how they work and what they do. I was also interested in how they would work in the real world. As I began to research the topic, I found many places that showed models of ideal pendula but not of real-world examples. A hurdle that I failed to overcome was that of modeling bearing friction or damping well in the equations of motion. Here are the ideal equations of motion, and the equations of motion with damping still haunt me at night. So I turned to a different method of analysis for the motion of a double pendulum. I went to SolidWorks and made a motion analysis. Here are the fruits of my labors. The nice thing about doing it in this way is that I can add a torsional damper to the cylinder at the head of either pendulum, and I can also know exactly how much damping there is on each pendulum because I can set it. In this case, the damping is 0.001 pound-force-second per degree. I know that is a strain unit for the top arm and 0.005 pound-seconds per degree for the bottom arm. And these numbers are the same for most of the simulations I will show. Double pendulum systems are famous for a thing called chaotic motion. As you can see here, there are two pendulum systems that are practically identical that behave very differently at slightly different initial conditions. You can see the difference in starting angle in the plots. It is very small. The difference in motion of the pendula, on the other hand, is not. In these photos, I used a long exposure filter to capture the motion of a double pendulum for the first 10 seconds of its motion. The difference in these photos is the mass of the top pendulum arm. This is the real-world prototype that I constructed, so the initial conditions are very difficult to get consistent. However, it is plain to see that the motion is greatly influenced by a tiny change in mass, just a few grams. The best way I could think to introduce more damping to the system was to jam some sawdust into the bearings. You are watching the video of the result now. I think I now know why people have not spent much time looking into double pendulums with significant damping. It is because they are super boring. Something that warrants further investigation is the behavior of a system like this, where only one of the two bearings experience significant damping.